Okay, so if we're studying series convergence and divergence, what do you think the integral test uses to prove that?
Integrals.
Woo! Revelation.
Derivatives.
The integral test uses an integral to show convergence or divergence.
Hooray, smart.
But there are some conditions for the integral test, so it has to meet. Okay, so the first, remember we're in a section that we're studying positive series,
Yes.
right? So, the first thing we gotta do is make that series a function. Okay.
Where'd your Sebastian come from?
Okay. That. Okay. Where
Just stop.
f of x is positive and decreasing and continuous.
That's what it needs.
Those are the conditions to use the integral test. So we have to have a function
Oh, decreasing.
that is positive, decreasing, and continuous. Okay. And we'll look at a few that shows what that means.
Do that.
Positive terms always. The function decreasing, you know what that looks like, right? The terms are going down. And then continuous, no breaks in the graph. Okay.
Does a cusp and a corner count as a break?
Yes.
No, so that's continuous still.
That's okay.
Right. But it's not decreasing.
Oh,
The cusp or- well, you could have, I guess you could have a corner and still be decreasing.
Okay.
Can you have a cusp?
No.
No.
I don't think you could. So, but you're not gonna run into that. Okay.
Yeah.
Continuous and differentiability.
Yeah, that's one thing.
And one thing,
What's that? Dude, do you agree on that?
What the heck?
Distraction.
Okay, you remember what, so from improper integrals, so you're gonna be using improper integrals a lot here. Okay. What does an improper integral converging mean?
What?
What does this mean? Do you remember? An integral that's improper converges. Nope.
Yep.
That means it gives us an answer. Not infinity.
Oh.
Right? An improper integral converges if it gives you a number.
Oh, yeah.
Oh, duh. I knew that, Mr. Arthur. I just refused to answer.
Oh, I was
didn't hear
confused
you.
what you meant.
Well, that's why I asked. Do you remember? So what do you think happens in the series?
The same thing.
Same thing. Okay, good. So we're using integrals to prove series convergence here. And guess what? I'll let you take a stab at this one. You betcha. It's kind of handy. Yeah, I know. It's mind blowing. Oh, boom, baby. Okay, so is a direct correlation between convergence of an integral, convergence of the series. And I forgot something. Don't mess that up.
Did we ever find out the uses of series and sum?
Did I look it up?
Series and sequence.
That's the question at B. No, I didn't. I've been too busy planning winter survival training. It's a little bit more fun, let's just be honest.
Yeah.
yeah,
Oh, yeah?
no, already
And
up
5
there.
copies was the supreme of fun.
But I can if you guys want.
Would you please?
I just have to put some thought into it. Okay, so let's consider the harmonic series. I have told you it diverges. Right? Well, this is how we prove it. Those cars, they tend to fight back. But I'm serious, sometimes they do. Break a nut loose, whack!
What is happening?
It's Jimmy.
Oh.
Okay, so, I've told you this diverges, now we're gonna actually show it. So we're gonna use the integral test. First of all, is the harmonic series serenaded positive?
Yes.
Okay, so each term produces a positive, right? Okay, decreasing.
Yes.
Yeah,
The bigger
one,
it gets, the smaller the value gets.
1/2, 1/3, 1/4. Yes, okay, good. And continuous?
Yes.
Yeah, 1/x is continuous, if x is a real number. That's all you really have to do, is mention that those three work. You don't have to calculate the derivative to show decreasing. Okay, so you just have to check them. You don't have to do the formal math.
You mean integral?
Huh? No, like decreasing, you remember how to check for decreasing function? Derivative equals 0, sign analysis. Okay. All right, so we're going to use the integral test because we can. And it's an improper integral. So you can get a lot of practice with those. Whoa, talk about accidents. How do we deal with improper integrals?
You make it a limit with R approaching infinity, or, yeah.
Yeah, you go. Good. Okay. Yeah, go ahead and solve that problem.
As I think about it, both the days we went to use of last year and this year, I was gone.
It's terrible.
Yeah.
No. I just don't want to have use of.
It's one of the better.
I understand it now. It was great.
I don't want one.
It almost sounds good. Where did this come from? I use orange.
Oh, I stole it from board.
Okay.
Mason likes to have conversations with himself.
Yeah, it happens. It's kind of weird.
Just let me block him out.
Makes me wonder if it's just himself or people that we can't see.
Have you seen the movie Split before?
I have.
Oh,
See you
he and I saw glasses Sunday.
Hey,
Was it good?
who's got it?
I don't know what natural light is. What do you do?
I feel like that 1 is 0.
What's natural light? Yeah, so you got a divergence.
Oh, that should be enough. Whoa.
What?
Totally screwed that up.
Infinity?
X,
R.
R. Right, so
But then there's an infinity
if
zero.
improper.
Yeah, infinity minus 1.
No, what's natural log 1?
Zero.
Oh, yeah, thank you.
Log at 1. Any logarithm at 1 is 0. Okay, so since the integral diverges,
The series divergence.
therefore I'm being cute and okay, I'm good. Let's slow down here a little bit. Diverges. And you're good. Okay. So now the harmonic series officially diverges because we've shown it. So basically what you're looking at is any series
We should play that.
that you can turn into a function that you can integrate. You need to take a long, hard look at the integral test. Make sure it meets the criteria, pull the trigger. Okay? And as with any integral, what different methods can we use to solve these integrals? Several. We've got an improper.
Oh.
What else? What if-
Definite, partial, definite.
We got partial.
Oh, you're
Partial
not.
fractions.
Watch it by the same video.
Wait, no.
No, it's
Integral.
to solve the sums.
Integration by parts,
Yeah.
use substitution, and any memorized integrals. All those are in play. Okay, so let's look at one that uses one of those methods. Does
Oh. Compounded interest. That's what we use series for.
huh?
Compounded interest. It's like when they go out like 25 years or whatever, they tell you how much you're gonna owe, they use a good approximation over the series.
It's interesting.
Is that squared? Is that the n squared plus 1? Is that squared or cubed? Okay.
Should have computers that do that.
It's a fraction.
I'm going into banking at all.
Yeah, because you
Told
use
me that
that, right?
yesterday.
Yeah.
Oh my
Use
gosh, you
substitution.
brain.
So again,
Everything's used so.
make this a function. Is it positive, decreasing, and continuous?
It is positive.
It is positive. It
Terms
is
of positive,
decreasing. It is decreasing
Decreasing.
because the bottom number will always
bottom's
be
bigger,
Oh, it is positive.
and
Oh, so it is continuous.
continuous because,
It can never equal 0 on the bottom.
right. Okay,
That's a useless.
so you do your checks, now you can do your integral test.
Do we have to write out the checks? Like, to get credit?
Yes, you should.
Really?
Or at least state it. If say, since the function is and it helps if you change it to x's.
Simply, so it's more in the form that we recognize.
No, so
Negative.
the series is
Yeah.
based on integers,
Yeah.
not continuous. So you have to change it into something that is. So a change in variable
Yeah.
will indicate that you have changed that
Negative one over
function.
u?
And X is what we use most of the time anyways, so.
Yeah.
Negative 1 over u. Times a half, so negative 1 over 2u.
Alright.
Do the limit from 1 to infinity. Yeah. You know, what's approaching zero?
Why did you change the boundary from 1 to 2?
So it's all
From
terms
no
of you.
because it's negative. Why are you going for two?
I still
X is 1.
Sure.
1 squared plus 1 is u is 2.
Oh, you're doing that thing.
No, I don't have to put x back in at all. Remember?
Yeah, I forgot.
So we can do it this way and change, so these are x values. If I change these to u values, I don't have to put x back in,
Oh, okay.
right? So I'm just gonna cruise and finish.
Yeah, you look at the fingers here. Looking at the number.
Get it?
No, hold on.
So it's a negative 1 over infinity plus 1/2 or 1/4.
Zero minus -1. So this should show where the series converges or just that the series converges?
Just that it converges.
So while we're
Therefore, series. Not really. You know what that means? Here, let me help you out.
Therefore,
Means the predator's on the loose.
Okay.
Yeah, therefore. You seen the movie Predator?
yeah, but it's
Yeah.
just a reference.
Does he have like a?
His targeting mechanism is the triangular.
That's an advanced level reference.
From the 1980s too. Okay, so that's using the integral test.
So does that just state if it converges? Or
That's
does it
it.
converge
Doesn't
to
tell you what number.
Okay.
The old, again, what tests have we used so far?
P series, integral test, and nth term.
Yours.
Well, there's one more.
Geometric series.
Oh, yeah.
Okay, this is the only one that tells us the number.
Geometric is?
This, the others are just converge or diverge. And even then, the nth term is only diverge. Okay. So this only tells us diverge. This tells us,
Both.
Geometric parts, can we include that, please?
okay,
Are we gonna go through all these tests and then make
that's
a card?
4. Tomorrow, comparison limit comparison test. It's 2 more, that's 6. The next day will be, this ratio, maybe, alternating series. 7, and then the last 2 are the ratio and the root tests, 9. Any one of them are fair game on that AP exam.
It just depends on which one fits.
That's the hard part, is determining which one fits the series. And then you gotta use it.
Will they ever state which one they would like us to use, or?
I will, there's your new problems, and then, did I give you the spiraling already?
No.
I'll give that to you now.
Is there more to this last night?
Yeah, tomorrow.
We get a part C.
Holy moly.
I usually do it in 2 days, but I split it to 3 because we just ran out of time yesterday. Not a big deal. It might help you to absorb. Because we would have had 2 yesterday and 2 today and 2 tomorrow. But this will split it up a little bit easier. Okay, so these are all, the new ones are all integral test problems. And then the spiraling, we'll look at it tomorrow. Do you guys want to start making cards?
Yes,
Are your series cards white?
yellow.
They're yellow.
You made pasta already?
Yeah.
I am not crazy, thank